Hello and welcome to Data Modeling as a Strategic Investment, how to measure ROI and defend data modeling projects to business stakeholders. Let's get started. A little bit about myself for those who don't know me. I'm Serge. I'm head of product at SqlDBM, an online database modeling tool. So we do database modeling in the cloud and we make it accessible, collaborative, and try to really encourage the team effort aspect of data modeling, sharing the knowledge. I'm a data architect by trade. Most of my career was spent in data and BI. I'm a Snowflake data superhero, and as I mentioned, I'm the author of Data Modeling with Snowflake for those who have team members from analysts to people new to Snowflake or just new to data modeling. It's a very good primer to get people up to speed on what exactly is data modeling, why do it, and the value it adds to enterprise data teams. And today, as I started saying earlier, for those who joined early, I will be drawing upon experience of all these roles I've had throughout my lifetime, but it's really as head of product at SqlDBM that I got a lot of the insights that I'm going to be sharing with you today. In my role as head of product, I not only influence kind of how the product gets built and the features that we prioritize and we create, but I also get to hear from our clients or potential clients. What are their pain points? What are they trying to achieve with data modeling in their company? What problems are they trying to solve? And it gives me almost an accelerated view of, I maybe get a chance to speak to a dozen or so different use cases in a given week or so. And over time, with that many use cases, you start to see a pattern because I speak to them throughout their journey as they're trialing the tool, as they are onboarding onto the tool, a year after they've been using the tool as a check-in. And I started to see some patterns that there were plenty of use cases at first that surprised me to hear that, they didn't succeed. They would come and say, look, we love the tool is great, but we couldn't convince our data teams to collaborate, or sorry, our business teams to collaborate with us. Or, we're using it internally, but we had all these modelers and then all these viewers in mind, but in the end, we couldn't really onboard people. And some of the things that started to come up was the recurring pattern of when we started to see somebody who was focused specifically on the technical aspect of data modeling, their focus was on features and not how to bring the business in to share their side of the business model. That's when we started to say, okay, we need to make sure that both data teams and business teams are aligned. So these were people that were senior architects in many cases. They didn't need to be taught data modeling. They needed to be taught how to quote unquote sell data modeling internally, even though they had already gotten the tool, they haven't gotten their business side on board. So that's what we're going to focus on today. Of once we started to see this pattern, we quickly knew when to step in and say, look, this is how, you're gonna love the tool regardless because you're gonna be doing what you do best. But here's your playbook for how to make sure that you get some of this business knowledge out of your business team's heads and into a common repository and common tool. So to understand the KPIs that we're going to be exploring, we're going to start with exactly what is data modeling. We're going to go beyond just the narrow definition of an ER diagram. We're going to talk about the practical benefits for enterprise teams, myths and organizational barriers, and ultimately how to convince using terms, metrics, KPIs that business teams already understand. In fact, they're probably gonna expect them from you instead of hearing all about features and different ways of that you would love to use the tool, but how would it benefit them? So let's go ahead and ask the not so obvious question of what is data modeling? And here I have what I think most people have in their heads of when they think data modeling, they think ER diagram. Sometimes maybe even in something in a printout and on a pasted on a blackboard, a whiteboard. What I hope that we take away today, if we take away anything, is that data modeling is what's happening on this photo. It's the conversation between what is our business model and then what is the data that we capture around it. The data team, as much as they can log into their database of choice, they cannot derive the what ought to be from just looking at the data. They just see what is. Is it right? Is it accurate? Is it complete? We don't know based on the data itself. We need somebody with business context to help us understand these things. But what else is data modeling? It is data lineage. So it's not just an entity relationship diagram. It is data governance, it's PII, it's tagging, it's assigning quality metrics like gold, silver, and bronze to trusted sources of data. It's everything that eliminates ambiguity and promotes self-service within a company and data analysis. So what is data modeling in a nutshell? Data modeling starts with the business model. It's what we do, plain and simple. Based on what we do, we create our data model. From our business model, we get our data model. Which aspects of what we do we care about? Which parts of it do we want to record, analyze, and collect data on? But beyond that, there's also vocabulary. Again, we're going way beyond just an ER diagram. So how do we encode the things when we meet a colleague in a hallway, when we discuss things over a dashboard? So let's look at this in context. Our business model, let's say for this example, is we sell shoes online. That's what we do as a company. Our data model is stems from that of we have concepts like order, SKU, category, and some things that we want to record around all of these processes. So for example, because we sell shoes, let's say there's the universe of everything we can capture about our customers, our product, our business is infinite. Do we care about our customer's favorite color? If we sell shoes, yeah, probably we do. If we stream movies, probably not that relevant. So the data model then speaks to what it is that we collect. And part of that we have the collateral. The fancy word is ontology. We have entities, relationships, we have data dictionaries, we have semantic models, everything that helps us look, encode, interpret, and share this information. It's not always going to be in a database table because databases are actually quite limited in the context that they can encode. Very little metadata besides a description and maybe a tag. But it doesn't end there. There's also vocabulary. There's things that a lot of you, if you're experienced in the world of data, already intuitively understand, like type 2 dimension. Just by saying those three words, I have communicated a whole wealth of information of what you would expect to see in such a table in a type 2 dimension. Both the columns that you would expect to see there, valid from, valid to a lot of maybe the underlying code of how do we merge things into the pseudocode or the actual SQL of how do we create the granularity of this table. So this is why it's so important to have the accurate semantics, whether verbal, physical, or shared in what we're communicating. Just so when I say type 2 dimension, everyone understands the same thing as they would, this is a technical term, but as they would, let's say, with active customer. This is a great one because I've never met a company that actually has one definition of an active customer. So which active customer do I mean? When they last logged in, when they last bought something, marketing has their own definition, sales has their own definition. But the important thing is we need to be able to agree that as long as we agree on which one is the official one, then we can, there's no need to come to blows. What happens when we don't agree? The common misconception that we see in, especially around data analysis, which tends to happen in a data warehouse, is we don't need data modeling because we have an ETL tool that lands data into our landing area. So I don't need to model. I don't need to create any collateral. I don't need a data dictionary. Let's say the ETL lands it in raw, then our stored procedures or whatever we're using for transformations transform it upstream. But the data, what we're missing is the fact that it's already been modeled. When we load the customer table, it's already been modeled to a certain spec. It contains certain columns, certain data types, certain relationships to other tables. So how do we encode that information and share it? That maybe when we're a small company, we're just starting out, everybody knows the 5 or 10 tables that we have and how they relate to one another. But as we grow, we can't scale that. We can't keep that information in any one person's head. So as Joe Reese famously said, a lack of a data model is still a data model, albeit a crappy one. The problems that arise are myriad. And I'm sure in any given organization, to some degree, all of these exist in some form or another. Duplicate data, the inability to self-service and discover data, uh, something that feels very natural, turning to the person next to you and saying, "Hey, where is this? Where is this attribute? Where is this data? Where is this dashboard?" Or having to organize a meeting around something like that. Poor data quality because of, let's say, our previous example. You said active customer. I understood the marketing version. You meant the sales version. And ultimately, who gets blamed? It's the data team because they're ultimately the ones delivering the dashboards, delivering the analyses in front of the users. Doesn't matter how far back the problem goes, they're ultimately just the closest person to blame. The part that we're going to focus on in this webinar is that data modeling is a team sport. As we said, a lot of this information, how to encode it, how to technically preserve it, is the job of the data team, but they don't own the understanding beginning to end. Data modeling, as we said, starts with the very concept of our business model, what we do, what we say, what we collect about what we do, the data we store, down to even the metadata we collect of what is our data quality? When did somebody last log in to check this metric? When was this last updated? All of this collectively, from we sell shoes to last login of this report or last access of such and such dashboard, is a data model and helps us understand and share what we're doing. The benefits. Surprise, surprise. Data for most organizations, most engineering teams is going to be not a profit center, but a loss center, a cost center. It's going to be something that we invest in to support our profit centers like sales, like um, our contractors and people who are going out and making deals or doing something, making money based on whatever the company does. The best way for a cost center to justify its existence is to demonstrate efficiency, meaning we're going to spend some time and we're going to build this data set or we're going to automate this process. And we are then going to save you. How long did it take you, you said, to do this manually? And how many times a week, a day, a month do you perform this? There's your answer. This is what we can achieve, and that is the ROI. But that's just numbers. Those are just metrics. The benefits of data modeling are much more nuanced than that. So it's everything from usability. How does it feel to work with the data? Can we trust it? Can we trust our colleagues in such and such team who are the data providers or data owners? How quickly can we deliver things? So how are we not tripping up and having to rework certain analyses or certain dashboards? Are we taking advantage of all the data we have? Let's say we bought a CRM system, but we don't know how to link it to the customers on the reporting dashboard. Do we know how to speak across teams? Are we following common conventions? So if they're doing great stuff over here, we're doing great stuff over here. There's commonalities. Do we know how to extract their data? Is there an API that we can connect to? How do we consume it? These are all the things that we unlock once we start standardizing and just opening up a common catalog, common understanding of what we're working with. In practical terms, what does this look like? I've taken Snowflake sample data as an example. This is a data set with less than 10 tables, but even here we have things like location. Imagine I walked in off the street, I'm a new consultant, I'm asked to do some analysis. Is the location a customer location or is this the supplier location? With a little bit of wrangling, I can figure this out. I can pretty much be confident in most of these relationships by the end of a day. But why should I spend a day guessing when the very same information displayed in a slightly different format can tell me everything that I need to know? Okay, so if data modeling is so great, why is it so often absent? Because, as we said, a lot of times people take it for granted that data modeling sounds like doing something. And why should I do something when I'm busy and I'm trying to, my deliverable is not a data model, it's a dashboard. Why should I take the time? Some of these are going to be important because we're going to look at misconceptions and then we're going to look at actual barriers that you're going to have to confront. Misconceptions are a little bit easier because you can explain them away. So these should be something that you can just not even worry about and breeze through when confronted. Number one, data modeling is just for the data team. That's what we started with. How can that be true if I need to speak to you as the subject matter expert to form my data model? How do I validate it? How do I then, when I share it with a business analyst to say, look, here's the data that you can discover, what we were looking at on the previous screen. Here's how you can perform this analysis. Here's where you can get this data. Another one is it's a one-time effort, one and done. Of course, if our business doesn't grow, we never create new products, we never create new market segments, maybe, but everyone, as long as there's a data team involved, chances are your business is growing and evolving. You're doing new things, new questions are being asked of the data. So you're always going to need to keep this current. Large projects and organizations. This one is the frog in boiling water. How, of course, if you're a startup, you have maybe 10, 15 tables, and you got three people sitting around the conference table. You probably don't need a data model, but you will tomorrow. You will grow. And when is the line between too little and not enough? The problem is you're going to feel the pain long before you realize there's a problem. By the time you realize you've outgrown your small little startup, now you've got a lot of tech debt of starting from scratch and having to basically go back and do the hard work of saying, is this even right, what we built? And the last one, this is what we're actually going to spend time exploring, that data modeling slows down data project timelines. And reasonable misconception because again, we're being asked to do something that may or may not be a line item in our project. So obviously, investing time in something is more time than not doing this. So this one we're going to look at in context. But real and actual barriers that you will face when you come to your business users or you go to validate a project proposal and data modeling is you're saying you're going to spend time on data modeling. So number one, it's the people who present data models are engineers, data teams, BI teams. They may or may not be versed in the language of the business. Things like ROI, things like the expected return, the initial investment. Why should the business collaborate with us? Why should they spend the time? Another problem you're going to face, especially as your organizations get larger, is not only are you going to have to solve this problem once, you're going to have to solve it over and over again because you have different data domains. Once you get one team on board, let's say you get sales or marketing or finance, How do you convince HR? How do you convince the procurement team that now they need to work with you? We're going to look at all of these once we understand some of the tools at our disposal. And finally, it's lack of top-down data strategy. Because if we're talking about having to convince the business teams ourselves as engineers, it's a very good sign that our data strategy is floundering from the top down. There is no head of data, there is no CDO who understands these things and mandates them from us, from everybody to say, look, we're going to be doing this and we're going to be doing it in an ordered fashion. So unfortunately it's up to us, but it's not something that we can't handle with the right tool set. Let's take a look at some of the KPIs that we're going to use to communicate our message to the business or to the budget committee or to project stakeholders. Some of you, again, might be seeing these for the first time, so we're just going to very briefly go over the important parts. The problem with quote unquote selling data modeling is that people tend to zero in on their day-to-day of, I could show you this diagram and explain your question. So something that might have taken me, 10 minutes to explain, I can show you a diagram. Or I tend to do this repeatable process this many times a day or a week, but how do you a week times some number of minutes? It's not really that profound. And the key to really selling it internally is looking at things holistically, taking an entire, let's say, data migration project or any kind of, let's say, data mart build out to say, this is not just something you do once or twice a week. This is something that we're going to build over the course of 6 months, a year, 2 years, something that's going to last the company for way longer than that, 5 years, 10 years, something that we're going to reuse over the course of its lifetime for self-service, for data governance, data stewardship. Now all of these things start to get the full weight of what they imply for the company and the bottom line. So in this context, the initial investment, this is if we're delivering a new project, we're not going to start realizing the value of the project from day one. We have to build it first. So we're going to spend, let's say if we're, in this example, we're going to use a medium-sized project. So a departmental data mart that we're building from scratch. So it's something, let's say, that's going to expected to take 1 year to build, and then it's going to last for, let's say, 5 years, that it's going to deliver value. If we maintain it, maybe a little longer than that. So the initial investment is the first year of we're going to be head down building the thing. Expected lifetime is how long will it last? For big projects, could be 5 to 10 years if we're talking about the entire data platform. For something smaller, 1 or 2, data mart, 3 to 5 years. Operating costs. We don't just walk away after we deliver it after the first year. We then have to support it with human capital. We have to support it with platform costs if we're using on-premise software, if we're using cloud software. All of these things have costs, licenses, training, infrastructure. It's going to cost something to keep the lights on. Bring that all together, that's your total cost of ownership. Everything from building the thing, using the thing, maintaining the thing, paying the licenses for what we're delivering. That's how much it's going to cost to get some of this value, supposedly, from what we're building. And what's the expected benefit? Well, I, as an engineer, as a data architect, I don't know. The business comes to me and says, we need a data mart. Why do you need it? What are you going to do with it? The business is going to tell you what the expected benefit is of if we had these analyses, if we had these predictions, we'll be able to increase sales or cut costs on procurement, whatever it is. This is something that we don't own. All the other metrics are entirely up to us as the data team. This one comes from the business. And ROI is simply dividing how much we spend versus how much we get back. If it costs us, let's say, $10 to build something and it's going to save us $5, that's not worth it. If it costs 10 and then saves us 100 and over the course of its lifetime, that's a good use of our capital. And this is something that we're going to use to defend some of the tools at our disposal, namely data modeling. And opportunity cost, this one is important because this is the hidden killer in what we're going to be discussing. Opportunity cost means we can't do two things with the same resources. We can either do one thing or another thing. The problem is when that one thing is fixes, repairs, rework, that's money that's not being spent on doing something useful, performing additional analyses, building, answering new business questions. It's going back to the blackboard. So what are we about to do with our little experiment? We're going to demonstrate how data modeling increases by an entire 5% the ROI of a given project. 5% might be a small percentage, but when we're talking about multi-million dollar projects over the course of 5 years, that is a very sizable chunk of money. We're going to show you how we uncover 400,000, which is, the price of an entire one FTE, one person, over the course of this maintenance period. Their life is going to be adding value to the company versus doing grunt work, repairing things, and getting yelled at. And we're going to show how every dollar invested in data modeling is going to generate 30% returns over the project itself. So what does this look like? This is a lot of numbers. Don't worry about getting it all in. This is part of the worksheet that we're going to be happy to share with you at the end of this presentation. So I'm just going to talk through some of the relevant points and numbers. Just like we described, we're talking about a data mart implementation that's going to take 1 year to build, and it's going to give us a return over the preceding 5 years, meaning years 2 through 6. And we're going to do two scenarios. Scenario A, which has no data modeling, and scenario B, where we include a line item for data modeling, and we're now going to have to defend this to our business stakeholders. So let's start by the phases, starting with development. Something is greater than nothing. We're spending money on data modeling on scenario B, and yet our cost of delivery is less than scenario A. Why is this? Because, as we said, with a common understanding, if we're building something that's going to take an entire year to build, this is a sizable project, we are checking first and building second. We're measuring, then we're cutting. We're validating something on paper before we actually have to build it and do the hard work. So yes, there is an additional cost in tooling, in training, in spending time and actually sitting with our business stakeholders and subject matter experts. But what does that result in? It results in not having to redo work because, as we're going to see from some of these examples, human costs are much higher than platform costs. If we have to take our developers, spend time doing something, and then spend time redoing something, that is double effort that we're having to spend. So in this scenario, all we're assuming is that we're just going to use this throughout the examples, that we're going to save 15%. If we do data modeling, it's going to result in a 15% faster time to delivery, time to market, which is a pretty conservative effort, but just so we can see the magnitude of how these things can add up once you really understand the value of what it brings to an organization. Next scenario is the operational costs, so years 2 through 5, the actual use of the platform that we're building. Here's the curious thing, that the operational costs of the platform actually don't change. So there's the data and engineering team, and then there's the operational costs of, if this was a SaaS like Snowflake, then the only thing that changes is we still have an additional line item for data modeling, but the appliance stays on. It stays on from during business hours, from 9 to 5, data warehouse, running jobs. The question is, what jobs is it running? Is it running analytics and delivering trusted results, or is it rerunning something that was wrong from last week? So yes, there is an increment in scenario B with data modeling because we have additional tools, we have a catalog, we have SqlDBM, hopefully. And so there is additional tooling. But what does it show us? If we look at what our engineers are spending their time doing, this is the hidden secret that hides in plain sight. When you have bad data, you don't go out and get more budget. You don't go to your boss and say, "Hey, my team is shit. Can I have more?" You steal that time from value added work that you could be delivering from the business. You have, in this case, 4 FTEs working throughout 5 years. That's $2 million, assuming 100K roughly for each FTE. That's what we're going to be spending on human capital. And this is where opportunity cost comes in. Are these humans doing productive work, or are they fixing yesterday's problem and spending not just 1x, but 2x the salaries on doing and redoing something? Finally, so this gives us, we add it all up, total cost of ownership. And here the numbers are still relatively simple, although we could argue, well, let's look at this on the next slide. The expected benefits, as we just said on the previous slide, our engineering team is not just sitting around saying, okay, we delivered our project, let's just sit around and do nothing. They're getting new business requirements. They're building new dashboards. They're adding new data sources. And in the data modeling scenario, of course, there's some things that everything needs maintenance. Everything eventually has mistakes and needs to be fixed. But with better data quality, it means we're actually spending all our time or most of our time on the value added work, meaning not only do we realize a benefit of getting the project delivered faster, we realize a benefit of adding value during the 5 years of expected lifetime. And this is the equivalent of not just what we said the expected benefits were over those 5 years, but also in all the additional work that we've been able to do that wasn't fixes, repairs, arguments, bantering back and forth and defending why it wasn't our fault. And this is the ultimate takeaway that here there's a 5% difference, as we said, 5% ROI savings. But there's something that is even deeper to understand. What opportunity cost, we saw it on paper, but what does it feel like to work in an organization with data quality issues? And I'm sure I don't need to belabor this point. Some of you know exactly what I'm talking about. It doesn't feel great to look at your colleagues and have this animosity of this blame, the defending versus trusting, um, spending time on trying to get them not to create their own shadow BI data sources, but to trust the single source of truth that you have. It's it's a much better working environment. People trust each other, they trust the data, they trust the data products that are being delivered. And as I said earlier, it's a process. It's a loop that we're going to have to repeat across business teams, across data domains. It's starting with what are the business metrics for the company as a whole, not just for our project, but what is the initiative of the company of, is it increasing revenue? Is it increasing efficiency? Is it scaling out the business? Use those KPIs to say, look, this is how data modeling can help because we've just made a very convincing case for all of those. Establish those metrics, tie them to the business metrics of what the company is doing, emphasize those benefits, and then demonstrate, just like we did with that Excel, use the Excel itself and demonstrate what that ROI would be in numbers, in dollars and cents. And most importantly, convince people what you have done because everybody likes a success story. Everybody likes looking good. Once you've convinced one business champion to work with you, that person will be happy to sing your praises and convince other teams of look how great we are, look how mature our data team is, and by extension, my analysts, like they worked with the engineers and look at everything they've been able to achieve. These are just some of the feedback that we've gotten from clients. Using data modeling, using SqlDBM, the business has a much better understanding of what's going on in the system and a much clearer idea of what they're looking at. collaboration, trust, single source of truth. SqlDBM came in a year ago and it became a critical part of the overall infrastructure, fundamentally the simplest part. It's not about the very first slide we started with, the archaic data models and conventions and standards, although those are all present in the tool, the takeaway is the collaborative aspect. We're going to look at that in just a second. So just to wrap up, what is the takeaway from all of this? Remember the most important point. Data modeling is a team sport. You can't win it alone, as doesn't matter if you're the greatest data architect in the world. You need to involve the business. The data team drives, the business team navigates, and buckle up and start that journey together. So thank you. This is the presentation part. We're going to now look at SqlDBM to see how it empowers some of these collaborative features. And we still have a good 20 minutes to go. And we're going to take questions from you about anything that we saw here today. Okay, so let's start with SqlDBM itself. As I said, it is a online database modeling tool, meaning it's delivered through the browser. There's nothing to download, nothing to install. It updates minimum once a month, transparently, no downtime. There's always new features landing. And the value out of the tool is everything that we've been talking about. It's the collaboration. There are plenty of data modeling tools, some older than others. From the very inception of SqlDBM, the focus has been on ease of access and ease of collaboration. The fact that it runs in the browser, runs on any system, I can just type somebody's email into my project and they have instant access to everything that I'm doing and they're able to collaborate with me. That's the true power of data modeling in a company. Let's take a look at some of the features that in fact, let me sit down for this just so it's easier to drive. Let's go ahead and start with, let's open any one of these projects at random. So SqlDBM is a tool that supports all of the leading cloud data platforms, as well as on-premise systems like Postgres and Oracle and SQL Server. We also have logical modeling, which we'll take a look at, with very easy import and export to physical, so you can keep everything in sync. So let's go ahead and open one of my existing projects. As a SaaS tool, you'll notice some of these versions. Everything is version controlled, stored by us forever, unlimited versions, unlimited projects. It's all in the cloud. You don't have to worry about it. It's there for you. There are roles, and let me just zoom in a little bit. Roles and profiles. I can just type somebody's name, whether it's a person or it's a team. I can add a whole group of people to this project all at once. I send the email, they get an invite. We're all collaborating on the same source of truth. It is a technical tool, of course, but the idea is to make it easy to use for anybody. We're looking at a diagram now, but maybe this is too technical for my business users. Let's just go with descriptions version of this diagram. Let's just show them the entities we have and how they're related, or let's do conceptual or logical to help them understand these things. And let's spend some time on the collaboration features. So not only is this a data modeling tool for a given project, it's a data modeling platform for teams that, let's say, have separate data domains. They're working in areas where they might not even know that certain information exists. So what you saw on the previous screen, I have in this example, you're seeing a feature within our global modeling suite called global references. So these objects with a little dotted frame around them, these are global objects, meaning they are read-only references from another project that I've imported here. So if I'm building something downstream from a data asset that another team owns, I can reference it. I don't own it. I can't change it, but I can build downstream of it. I can consume it, and I can, you notice this little refresh icon. This is telling me this item, this object has changed in the source project. I need to update it to the latest version and get whatever new attributes or update my model accordingly or new relationships that it might have to other objects. Very powerful feature for data mesh and distributed data domains, and something that we're launching this very week. In fact, we're going to get our a little early preview of the newest offering in global modeling, which is global standards. Kind of driving off of this simple, how do we have one place, one source of truth for a given object? How do we enforce standards across projects, across teams? So this is the latest thing that we're very excited to unveil. Global standards, let's go ahead and create a global standard, is a way to do exactly that. One place to define templates, to define glossary terms, to define naming conventions, uppercase, lowercase, and then enforce it down so that I, as the data architect, don't have to run around and check, did the new object that my team create, does it meet my standards? Is it reusing existing templates that and not building things from scratch? Global standards, because it's brand new, we can even create it from an existing project. So if you have a master project where a lot of these standards already exist, just import it, or we can start from scratch. So let's go ahead and just pick a project type. In this case, this is Snowflake. Standards are database project specific. And they include things like glossary terms, column templates, table templates, flag definitions. Let's just save this guy. So that anything that I create here, let's say I create a new column template, table template, create a new column template, let's say ETL fields. Let's give this ATL ID, which is varchar, down to even glossary terms. Let's say emp, we'll change that to employee to emp, and that will be our physical only. So we're not going to go through every single feature, but once I've created a standard, well, let me make sure I save it. The objects here are for reference. So once I've applied, let's say let's say I make everything uppercase. These are just a preview of what's going to happen in mapped projects. So if we go to our global standards for the one we just created, let's go ahead and apply this on the project that I was just showing you. So now when I log in here, even though this project already had glossary terms of its own, it had templates, it had everything. Now this is using standards. So I can not save, I cannot continue working on this project until I've done what my architect has asked me to do and applied these standards. So everything that we created on the previous screen, everything in uppercase. And once I hit save, this is telling me all of these things now need to be renamed. So this is a lot of changes all at once, but everything now is going to get converted to uppercase and everything that we set here. I didn't override any glossary terms or templates I had earlier. They're still here, but the concept is global standard over local standard. As long as they're not in conflict, they can coexist. If they are, global standard takes precedence. Finally, how do I share some of this stuff? So, for example, we have the iframe that we recently released. Let's go ahead and look at what iframe looks like. I'm done data modeling. I want to share this in my data catalog. I want to share this in my internal wiki page. This is a secure token secured rendering of my project that I can share with my business users. Maybe they don't even know what SqlDBM is. They just know Calibra or they know whatever catalog you're using. Now they can all do the exact same thing that I was doing earlier and discover data assets, understand the relationships and how they interconnect. Okay, I'm still doing good on time. So let's go ahead and take a look at some of the DBT stuff. For those of you, I'm just jumping around just to kind of give an overview of all the time saving and useful things you can standardize in a single project. If I am using DBT and I'm doing proper modeling and I am creating a new dimension, let's say, based on something that my business has asked of me, how much faster is it to show something like this to a business user before I've actually written the SQL to say, did you ask for 5 fields or 10 fields? Are you expecting ISBN to be an integer or were you expecting a string? And if the answer is yes, then I'm free to go ahead and now put the actual script together that can create this. So for DBT, we can also start adding some of our DBT properties like configs, or if these were sources, we can apply which sources these are. Let's just take some of these at random freshness checks. And so I can maintain what I'm doing here all in a single place let's go ahead and rename that to the standard, that when I forward engineer, I can generate the SQL script, I can generate the alter script, I can generate YAML, whether that's source YAML or model YAML, and I can have all of these things all ready to go from a perspective of the analytics engineer who's going to take this YAML and build the object. I can push this straight to the Git repository where that person will be working. And if we're using, for example, DBT contracts, then all of these will be enforced, meaning the DBT build will fail if I have 10 columns instead of 5, or if this is not a bar chart. Let's make sure to include these data types actually when we do that, just so you see what I'm referring to. The idea is, again, not to do double work, making sure we built something, we validated it, and now we're sharing it. And on that topic, I guess the last feature we have time for is sorry, not global, data governance fields. Governance fields are, as we mentioned earlier, if we want to go beyond the DDL description or comment on an object or column, how can we do that? Governance fields give you a way to let's create a new field from scratch, extra metadata that we can add to our object. So this could be a text, this could be a URL, this could be anything. Drop down, we can have it apply to the object only or to objects and columns or columns only. And we can give it a default if we need to, so that we can maintain things like medallion, like something that's been validated. If this was a URL, we can add, for example, a link to the page where the data team that owns this entity maintains it or maintains documentation or anything like that, or the tool itself. This is part of some kind of broader context. So very powerful feature that this is even controllable by non-modelers. So we have a separate user profile called governance that they cannot make changes to the project, but they can create and maintain fields and extra documentation in pages. So these are just rich text kind of descriptions about the project itself. So Whirlwind Tour, I know I probably left more out than I mentioned, but just to give you guys an idea. Thank you so much. I hope you enjoyed the webinar. Please stay in touch, and for more information, visit SqlDBM.com and stay in touch.